This is the video for section 12.4, spheres. A sphere is the set of all points in three-dimensional space that are a fixed distance r from a given point in any direction. That fixed distance r is called the radius of the sphere, which functions like a radius for a circle does. So we have the radius in that direction, in that direction, in that direction, in that direction, and they're all the same, no matter which way we go. The surface area of a sphere, so the area around the outside of the sphere, is 4 pi times the square of the radius. And the volume contained within the sphere is 4/3 pi times the cube of the radius. So the surface area, 4 pi r squared. The volume, 4/3 pi r cubed. You need to know those formulas. Now let's use them. Example number 1. Find the area and the volume of a sphere with a radius of 2 centimeters. So we have the formula for the area, which was 4 pi r squared, and we'll just plug in the radius of 2. 4 pi times 2 squared. 2 squared is 4, times 4 is 16. 16 pi. Now we had units in the problem, so we'll put units on our answer. And the units for area are always squared units. 16 pi square centimeters. The formula for volume was 4/3 pi r cubed. So 4/3 times pi times 2 cubed. Well, 2 cubed is 2 times 2 times 2. That's 8. So we have 4/3 times pi times 8. Treat that 8 as 8 over 1, so we can multiply it by the fraction 4 over 3. That gives us 32 over 3. And we stick a pi on there. The units for volume are the original units cubed. So 32/3 pi cubic centimeters. Easy enough? Good. Example number 2. The area of a sphere is 256 pi. Find the volume. So the area is supposed to be 4 pi r squared, but they tell us the area is 256 pi. So that must equal 4 pi r squared. So then we have a formula that we can solve for r. We can cancel the pi's because they're multiplied on both sides. So we can divide both sides by pi and they're gone. We've got 256 equals 4r squared. Let's divide both sides by 4. What's 256 divided by 4? 64 equals r squared. So r is the square root of 64, which we all know is 8. So the problem asks for the volume. The volume is 4/3 pi r cubed. Alright, so 4/3 times pi times 8 cubed. 8 times 8 is 64. 64 times 8 is 2048. Nope. 64. 8 times 8 is 64. 64 times 8 is 512. Again, treat it as 512 over 1, so it can be multiplied by the fraction 4 over 3. That multiplies 4 times 512. That's 2048, 2048 over 3 with a pi on there. And that's the volume. And example number 3. A plane passes 4 centimeters from the center of a sphere with a radius of 7 centimeters. Find the area of the circle of intersection. What does that even mean? Here's a picture. You got the center, you've got the radius of 7. We've got a distance of 4 from the center to the plane. The plane is the flat surface that we're using here to cut through the sphere. We want to find the area of the circle that's formed when that plane intersects the sphere. So the circle is represented here by that orange shaded part. It's a circle So to find the area, we have to know the radius, and it's just pi times the radius squared. The radius is represented by x in our picture. So we can see there's a right triangle. We know the hypotenuse and one of the legs. We can find the other leg using the Pythagorean theorem. 4 squared plus x squared equals 7 squared. So 16 plus x squared equals 49. So x squared equals 49 minus 16, which is 33. So x, the radius of the circle, is the square root of 33. Notice the radius of the circle is not the same as the radius of the sphere. We want to find the area of that circle, which is just pi r squared, just an ordinary circle. Pi times radical 33 squared. What happens when we square a radical? The radical just goes away. It becomes just 33. So 33 pi. There were units in our problem, so we'll put units in our answer. The area is always the units squared. 33 pi centimeters squared. So here are your immediate practice problems. Find the area and the volume of a sphere with a radius of 1/2 inch. Just plug into the formulas. The area of a sphere is 64 pi. Find the volume. So work it like we did example number 2. And that's the end of section 12.4.